In 1933, a physicist at Caltech weighed a cluster of 1,000 galaxies and found that most of it was missing. Not lost, missing as in present, enormous, and completely invisible. Fritz Zwicky calculated that the Coma cluster was hundreds of times too heavy to be held together by anything that gives off light. He named the invisible majority dark matter. And his measurement was right to within a few percent of what our best instruments say today. It should have rewritten physics overnight. Instead, his field shrugged, cited a safer name than his, and pushed the man who found it down into a basement for 40 years. But the universe would not stop saying it. Vera Rubin proved him right in 1970, with spiral galaxies spinning fast enough to tear themselves apart. The bullet cluster made it undeniable in 2006. Yet today a 10-ton tank of xenon, buried a mile underground, sits in the dark listening for this stuff and hears nothing. We have known since before your grandparents were born that roughly 85% of the matter in the universe is something no one can see, catch, or name. It is moving through your body right now. And almost no one ever made you feel the size of that. So get comfortable, and if you have not already, subscribe or join so you are still here when the rest of this lands. There is a Patreon as well, where these explorations run deeper and wider across the cosmos, deep time, and the corners of physics that keep people up at night. Stay to the end, because by then you will understand that you are the rare 5%, the exception, and that the thing outweighing you 5-1 has never once told us its name. Let's go back to where this began. Somewhere in the constellation of Coma Berenices, about 320 million light-years from the chair you are sitting in, there is a swarm of more than 1,000 galaxies, and every single one of them is moving wrong. They are moving too fast, not a little too fast, catastrophically, impossibly too fast, fast enough that the entire swarm should have torn itself apart and scattered into empty space billions of years before the Earth existed. Each galaxy in that cluster is tearing through space at something close to 1,000 kilometers every second, which is about 2 million miles an hour, fast enough to cross the United States in roughly 4 seconds. And there is nowhere near enough visible matter in that cluster to hold any of them in place. The combined gravity of everything you can see in the Coma cluster, every star, every glowing cloud of gas, every single point of light that a telescope can register, is far too weak to keep those galaxies from flying off into the dark. By every law of physics we actually trust, that cluster should not exist. It should have come apart a long time ago. It is still there, and the reason it is still there, the reason it has not flown apart, is that something is holding it together. Something with enormous mass and enormous gravity. Something that gives off no light, absorbs no light, reflects no light. Has never been seen through any telescope ever built. Has never been caught in any detector ever constructed. And to this day, more than 90 years after we first noticed it, nobody on this planet can tell you what it is. That something is not rare. It is not some exotic edge case tucked into one strange corner of the sky. There is roughly 5 times more of it in the universe than there is of everything else put together. 5 times more than all the stars. 5 times more than every planet, every cloud of gas, every speck of dust, every atom in every galaxy, and every atom in your own body. The matter you can see, the matter you are made of, the matter that every science class you ever sat through was quietly, secretly about, is the minority. It is the contaminant. It is a thin, bright film floating on the surface of an ocean of something we cannot see, and the only reason you are here to wonder about any of this is that you happen to be built out of the rare stuff. A man worked this out in 1933. One man. Working with glass photographic plates, a sample of 8 galaxies, and a piece of 19th century mathematics. A Swiss astronomer at the California Institute of Technology ran the numbers and arrived at a conclusion so far outside what anyone was prepared to accept that his entire field decided, more or less collectively, to look away from it for the next 40 years. He gave the invisible thing a name. He published the name in a journal. The name was correct. The measurement was essentially correct. The implication was correct. And for 4 decades, the people who should have understood it best treated his discovery the way you treat a smell in a house you do not want to investigate. They knew it was there. They walked past it. They redecorated around it. His name was Fritz Zwicky. And by the end of this, you are going to understand why the story of how he was treated is, in its own quiet way, almost as disturbing as the thing he found. Because the man who proved that most of the universe is invisible was himself slowly, deliberately, made invisible by the field he belonged to. That is not a metaphor I am reaching for to sound clever. It is close to a literal description of what happened to him, and the way it happened should bother you, and it is going to get worse than it sounds right now. But before any of that, you need to sit with the central fact, because the central fact is the thing that everything else hangs from, and it has not changed in 90 years. Most of the matter in the universe is missing from every picture you have ever been shown. Not missing as in lost, missing as in present, and dominant, and completely invisible. And the more we look for it, the less we understand it. Let me show you how he found it, because the method is almost insultingly simple, and that is part of what makes the silence that followed so hard to forgive. In the early 1930s, Fritz Zwicky was a young, abrasive, dangerously brilliant physicist who had come to Caltech from Switzerland and had developed an interest in the great clusters of galaxies, those enormous gravitationally bound cities of stars hanging in the deep sky. The Coma cluster was one of the richest he could study. Even with the equipment of the time, you could see that it was packed with hundreds upon hundreds of galaxies, each one of them a separate island of billions of stars, all of them swarming together in a region of space tens of millions of light years across. Today we know the cluster even better, and the modern picture only makes the swarm more staggering. A catalogue published in 2024 lists more than 2,000 member galaxies in Coma. The whole structure spans something like 20 million light years, which is a distance so large that light itself, the fastest thing there is, takes 20 million years just to cross from one side of the cluster to the other. At its heart sit 2 supergent elliptical galaxies, monstrous things far larger than our own Milky Way, and one of them, catalogued as NGC 4889, harbors at its center one of the most massive black holes ever found, a gravitational pit estimated at perhaps 20 billion times the mass of the Sun. This is the object Zwicky was weighing, not a tidy little cluster, a churning cosmic city the size of which the human mind cannot really hold, full of giant galaxies and supermassive black holes, all of it moving, all of it bound together by a grip far stronger than anything visible inside it could possibly exert. Zwicky wanted to weigh it, not metaphorically. He wanted an actual number for the total mass of the entire cluster. And he had 2 completely different ways of getting that number, which is exactly where the trouble started. The first way was to add up the light. You count the galaxies, you estimate how many stars are in each one, you know roughly how much mass a star of a given brightness has, and you add it all up. This gives you the luminous mass, the mass of everything that shines. It is the obvious method. It is the method that assumes, reasonably enough, that the stuff giving off light is the stuff that is there. For most of the history of astronomy, that assumption was so natural that nobody even bothered to state it. Light was the inventory. If it glowed, you counted it. If it did not glow, it did not exist, because how could you possibly know about it? The second way was older, stranger, and far more powerful. It came from a result in classical mechanics called the virial theorem, which had been worked out in the 1870s by the German physicist Rudolf Clausius. The virial theorem describes any stable system held together by gravity, a system that has settled down into a kind of long-term balance. And it says something very specific. It says that for such a system, there is a fixed relationship between how fast the members are moving and how much total mass is pulling on them. The faster the things in the system move, the more gravity is required to keep them bound. The more gravity, the more mass. It is, at its heart, a statement about balance. A bound system is one where the outward tendency of everything to fly apart is exactly counterweighted by the inward pull of everything's combined gravity. Measure the speeds, measure the size of the system, and the mass falls out of the equation, whether or not that mass is giving off a single photon of light. There is a reason almost nobody had pointed the virial theorem at a cluster of galaxies before Zwicky did. The mathematics had existed for decades. The French polymath Henri Poincaré had applied virial reasoning to astronomical problems more than 20 years earlier. But there is a difference between owning a tool and being willing to use it on a target that might give you an answer you do not want. And Zwicky, for all his faults, was never afraid of an answer he did not want. That was, in fact, the one consistent virtue running through his entire abrasive life. He went where the arithmetic pointed, even when the arithmetic pointed somewhere absurd. And he did not flinch when it got there. Notice what the method actually means, because the meaning is the whole story. The virial theorem does not care about light at all. It weighs a system by its motion. It is, in a sense, an honest accountant in a way that counting light never can be, because gravity does not lie and light does. Light tells you only about the things that shine. Gravity tells you about everything that is actually there. And the gap between those two answers, when there is a gap, is not noise, it is not sloppiness, it is a direct measurement of the things that are present and refuse to shine. The size of the gap is the size of the darkness. Think of it this way. Imagine you are standing in a completely dark room and you cannot see anything, but you can hear a heavy object swinging on a chain, faster and faster, in a wide arc around some central point. You cannot see the central point. You cannot see what is anchoring the chain, but from the speed of the swing and the width of the arc, you can calculate, with real precision, how strong the anchor in the middle must be. You can weigh the thing you cannot see, purely from the motion of the thing you can. That is the virial theorem. That is what Zwicky did to the Coma cluster. He listened to how fast the galaxies were swinging, and he calculated how heavy the unseen anchor had to be, and the anchor turned out to be far, far heavier than anything giving off light. So Zwicky did both. He counted the light in the Coma cluster, and he measured the motion in the Coma cluster, and he expected the two answers to agree, more or less, the way two careful measurements of the same thing should. They did not agree. They were not even close. Here is what he found, and these are real numbers from the real paper, because this audience deserves the real numbers. Zwicky measured the velocities of the galaxies in Coma by looking at their redshifts, the stretching of their light that tells you how fast they are moving toward or away from you. From a sample of just 8 galaxies, he found that they were spread across an enormous range of speeds. The spread, what astronomers call the velocity dispersion, came out to about 1,019 kilometers per second, with a generous uncertainty of plus or minus 360. I want you to hold on to that number, 1019 kilometers per second, because there is something genuinely eerie about it that we will come back to. Then he asked the obvious question: how much mass would the Coma cluster need to have in order for galaxies moving that fast to stay bound to it instead of escaping into space? He ran it through the virial theorem, and the answer that came back was that the cluster needed to contain at minimum about 400 times more mass than all of its visible stars could possibly account for. 400 times. Sit with the size of that gap for a second, because it is not the kind of discrepancy that a careful person waves away as measurement error. If you weigh yourself on a bathroom scale and on a doctor's scale, and one of them says you are 400 times heavier than the other, you do not conclude that scales are unreliable. You conclude that something extraordinary is going on. Zwicky was looking at a gap of that magnitude written into the sky, and he understood immediately what it meant. It meant that the overwhelming majority of the matter holding the Coma cluster together was not shining. It was not in the stars. It was something else, present in vast quantities, exerting tremendous gravity, and completely dark. He wrote it down in a paper published in 1933 in a Swiss journal called Helvetica Physica Acta, Volume 6, pages 110 through 127. The title, translated from the German, is The Redshift of Extragalactic Nebulae, because in 1933 the word galaxy was not yet standard, and what we now call galaxies was still being called nebulae. And buried inside that paper, in a section about the Coma cluster, is the sentence that started everything. Translated, it reads that if the cluster's mass really is what the motion implies, then we arrive at the astonishing conclusion that dark matter is present in much greater density than luminous matter. Dark matter. In the original German, Dunkel Materie. That is where the term that now dominates modern cosmology was placed into the scientific record, in a paper that almost nobody read, in a journal almost nobody outside Switzerland subscribed to, by a man almost nobody wanted to deal with. 4 years later, in 1937, he tried again, this time in English, this time in the Astrophysical Journal, the flagship journal of American astronomy, in a paper titled On the Masses of Nebulae and of Clusters of Nebulae. He could not be accused this time of hiding in an obscure Swiss publication. He laid the argument out again, more carefully, more conservatively. He assumed the Coma cluster held about 1,000 galaxies. He deliberately threw out one galaxy that was moving anomalously fast, at over 5,000 kilometers per second, just to be cautious, just to make the case harder for himself rather than easier. And even after stacking every assumption against his own conclusion, he arrived at a total cluster mass of about 45 trillion times the mass of the Sun, and a ratio of mass to light of around 500. A ratio of mass to light of 500 means that for every unit of brightness the cluster puts out, it contains 500 units of mass. The thing was 500 times heavier than it had any business being, based on its light. He wrote it down in the most respectable venue in his field, in plain English, with the numbers fully shown. And it changed nothing. The silence held. And here is the part that should already be bothering you. He was right. The specific number was wrong. Badly wrong, in fact. And we are going to spend real time on exactly why it was wrong. Because the wrongness is where the field found its excuse. But the conclusion, the actual thing he was saying, that the universe is full of invisible mass that outweighs everything we can see, that conclusion has survived 90 years of the most aggressive scrutiny that science can bring to bear, and it has come out the other side stronger every single time. The man was looking, in 1933, at a direct measurement of the most abundant form of matter in existence. He knew it. He published it. He named it. And the response of his field was, to a first approximation, nothing. That is the thing I keep coming back to, and the thing I want you to keep coming back to as well. This was not a vague hunch in a notebook. This was a measurement, in a journal, with a number attached. The proof that most of reality is invisible was sitting in the published literature, available to anyone who cared to look, for the better part of half a century. And the field walked past it. To understand how that is even possible, you have to understand the man, because the man is a very large part of the answer, and the man is one of the strangest characters in the history of 20th century science. Fritz Zwicky was born on February 14th, 1898, in Varna, on the Black Sea coast of Bulgaria. His father was a Swiss businessman who had done well enough abroad to serve as the Norwegian consul in the town. His mother was Czech. At the age of 6, young Fritz was sent back to Switzerland, to his father's ancestral canton of Glarus, to be raised by his grandparents and educated, the plan being that he would eventually go into the family commercial business. The plan did not survive contact with the boy's brain. He was too good at mathematics and too good at physics, and instead of commerce, he ended up at the Swiss Federal Institute of Technology in Zurich, the same institution that had recently produced Albert Einstein, where Zwicky studied under some of the finest minds in Europe and completed a doctorate on the application of the brand new theory of quantum mechanics to the structure of crystals. He studied mathematics under Hermann Weyl, one of the towering figures of 20th century mathematics, and did his doctoral work under Peter Debye, who would go on to win a Nobel Prize in chemistry. There is a detail about those Zurich years that I love, because it captures how strange and electric that little city was in that moment. While Zwicky was walking to lectures, Vladimir Lenin was living a few streets away on the Spiegelgasse, waiting out his exile before the train that would carry him to the Russian Revolution. And down the same narrow street, at a bar called the Cabaret Voltaire, a group of artists was inventing the Dada movement, tearing up the rules of what art was allowed to be. Zwicky came of age intellectually, in a place where the old order was being torn down on every front at once, in politics, in art, in physics, and he never lost the sense that the rules everyone agreed on were probably worth breaking. In 1925, a fellowship from the Rockefeller Foundation brought him across the Atlantic to the California Institute of Technology in Pasadena. The way he got the fellowship is itself a small portrait of the man. As the story goes, 2 executives from the Rockefeller Foundation were visiting ETH, and Zwicky was assigned to show them around, and he impressed them so thoroughly, so aggressively, with the force of his intelligence, that they more or less arranged the fellowship on the spot. He talked his way to America by being the most overwhelming person in the room, which would turn out to be both the engine of his career and the thing that wrecked his relationships in it. He never really left Pasadena. He would spend essentially his entire career at Caltech, eventually becoming the institution's first professor of astrophysics in 1942. Working a short drive from the great telescopes on Mount Wilson, and later the giant 200-inch instrument on Palomar Mountain, which for decades was the most powerful telescope on Earth. He had, on paper, everything a scientist could want: access to the best equipment in the world, a position at one of the best institutions in the world, a mind that nearly everyone who met him acknowledged was extraordinary. He married twice. In 1932, the same year he was deep in the Coma cluster data, he married Dorothy Vernon Gates, the daughter of a California state senator. And here the universe arranges one of its small jokes, because the Gates family money helped fund the construction of the Palomar Observatory during the Great Depression. the very mountain Zwicky would later be barred from, in his bitter old age, was partly paid for by his first wife's family. That marriage ended in divorce in 1941. In 1947, he married Anna Margaretha Zurcher, a Swiss woman, and they had 3 daughters. He was a serious mountaineer who made first ascents in the Alps, including one with a future Nobel laureate. And he was known to do one-handed push-ups in the Caltech cafeteria to demonstrate that his body was as uncompromising as his opinions. He was, in every dimension, a man who refused to be ordinary and who refused to let anyone around him forget it. And he was, by a wide margin, one of the most difficult human beings any of his colleagues had ever encountered. This matters. It is not gossip, and it is not a detour. The personality is woven directly into the science, because the way Zwicky treated people is a meaningful part of the reason his ideas were so easy for the field to ignore, and the way the field treated him in return is a meaningful part of what makes this story a tragedy rather than just a footnote. So you need to understand what he was like, in his own words, and in the words of the people who had to share a building with him. Zwicky had a favorite insult, and it tells you almost everything. He called the astronomers he disliked spherical bastards. When asked what he meant, he explained, with evident satisfaction, that they were bastards no matter how you looked at them. The way a sphere looks the same from every direction. Think about the mind that produces that insult. He took the language of geometry, of symmetry, of the very physics he worked in, and he weaponized it into contempt. It was not a careless slur. It was constructed. It was, in a horrible way, elegant. He did not reserve this for nobodies. As a young researcher, not yet established, he reportedly told the Nobel laureate Robert Millikan, the head of the laboratory in which Zwicky himself worked, that he had read every paper Millikan had ever written and had never once found a single original idea that Millikan could honestly call his own. Millikan, to his credit, simply replied, "All right, how about you?" He called the people who believed in the expanding universe horses' asses. He dismissed the contents of the major astronomical journals as useless trash, and he carried on like this for decades, alienating, by the end, almost everyone who might otherwise have championed his work. The most consequential of these feuds was with a German-born astronomer named Walter Baade, and the Baade feud sits right at the center of Zwicky's life, because Baade was not only his enemy, he had been his greatest collaborator. The two of them together produced some of the most prophetic work in the history of astrophysics, work we will get to, work that on its own should have made Zwicky one of the most celebrated scientists of his century. And then the relationship collapsed, sometime around the Second World War, and the collapse was total. Zwicky began calling Baade a Nazi, which Baade was not. A Caltech colleague named Jesse Greenstein later recalled that the situation got so poisonous that Baade became genuinely afraid for his physical safety, afraid that Zwicky might actually kill him, and that the two of them became, in Greenstein's words, a dangerous pair to put in the same room. At one point, a rattlesnake was found inside the dome of Zwicky's favorite telescope, and Zwicky accused Baade of having planted it there. I am not telling you this to entertain you, although I admit it is a strange kind of entertaining. I am telling you because the man who measured the invisible majority of the universe was also a man whom his own colleagues described, in retrospect, in language like this. Greenstein, who knew him for years, said plainly that he disliked Zwicky as a human being, that Zwicky was vain and self-centered, and that while Zwicky had an enormous facility for producing radical new ideas, a lot of people around him wished he had not been so rough in the process of producing them. Another contemporary called him an irritating buffoon. One biographer settled on the phrase both brilliant and insufferable. I should tell you that there is a dissent on this portrait, and the dissent comes from the person who knew him most intimately. Because fairness demands it, and because it complicates the easy picture in a way I think is important. His daughter, Barbarina, has spent years pushing back hard against the cruel caricature of her father. She has called the most famous published depiction of him a vile and slanderous attack. She insists that he used the spherical bastard line only a couple of times, and only ever about politicians, and she remembers a warm, funny, devoted father, not a monster. And I think you have to hold that too alongside the colleagues' accounts, because the truth of a difficult person is almost never as clean as either his enemies or his family want it to be. But here is the detail from her own defense that I cannot stop thinking about. She has said that when she and her father walked down the hallways of Caltech together, everyone would scatter. She meant it as a fond memory. But sit with the image for a second. A building full of brilliant scientists, scattering, getting out of the way, when this one man approached. Whatever the man was really like at home, that is what the field around him had become by the end. A space that emptied when he entered it. Now hold that picture in your head, because there is another picture, and the two of them do not fit together, and the fact that they do not fit together is one of the most human things about this entire story. The same man who called his colleagues spherical bastards spent the years after the Second World War running a personal humanitarian operation of genuine seriousness. He founded a committee to rebuild the scientific libraries of Europe that had been destroyed in the war. According to a colleague who watched him do it, Zwicky personally collected and distributed more than $1 million worth of scientific books and journals, packing them, cataloging them, wrapping them, and mailing them himself, first to the libraries of Allied nations, and then, pointedly, to the libraries of former enemy nations as well. He worked with a foundation that cared for war orphans and received a medal for it. Every year his department would fill up with children's knitwear that he was collecting to send to schools full of orphaned children in Europe. He hated nuclear weapons. He distrusted institutions and believed that the real hope for the world lay with free people of goodwill working together as needed. Without committees, without bureaucracies, without the machinery he spent his life fighting. So which one was he? The cruel one or the generous one? The answer, of course, is both, at the same time, all the time, and I think you cannot understand what happened to his dark matter discovery unless you understand that he was both. Because a field full of human beings, offered a revolutionary idea by a man who has called many of them bastards to their faces, is a field that will find reasons not to listen. And it found them. Here is where I have to be careful with you, and careful with the story, because there is a version of this tale that gets told constantly online and in popular science. And the popular version is a little too clean, and I think you are smart enough to want the real one. The popular version says that Zwicky discovered dark matter in 1933 and was openly laughed at and ridiculed for 40 years because he was an unlikable outsider until he was finally vindicated. It is a satisfying story. It has a clear villain, which is the cruel establishment, and a clear hero, which is the misunderstood genius, and a clear moral, which is that you should listen to the weird, abrasive person because he might be right. I would love for that story to be exactly true, because it is a great story. It is not exactly true. And the way it is not true is more interesting than the myth. The careful historians who have actually gone through the archives, people like Jaco de Swart and Gianfranco Bertona and Jeroen van Dongen, who published a detailed history of all this in the journal Nature Astronomy in 2017, make a more precise and more uncomfortable point. Zwicky was not so much actively ridiculed as he was quietly, persistently distrusted and then neglected. The field did not stand up and laugh at him. The field heard an extraordinary claim, looked at the shaky foundations underneath it, and decided, with a kind of collective shrug, to file it under unresolved and move on. And the reason that is more uncomfortable than open ridicule is that open ridicule at least means people are paying attention. What Zwicky got was worse. He got a polite, professional, well-reasoned silence. He got the benefit of the doubt withheld. He got shelved. And the truly difficult part, the part that makes this hard to turn into a clean morality tale, is that the field had real reasons, not good enough reasons in the end, but real ones. And you need to understand them, because they are the excuse the silence was built on. The first reason was that Zwicky's number was wrong. That factor of 400, the one that should have set off every alarm in astronomy, was inflated, and it was inflated because of a mistake that was not really Zwicky's fault at all. To measure the distances to galaxies, and therefore their true sizes and masses, you have to know the rate at which the universe is expanding, a number called the Hubble constant. In the 1930s, the best available value for the Hubble constant, the one Edwin Hubble himself had measured, was about 558 kilometers per second per megaparsec. The modern value, the one we trust today, is about 70. Hubble's value was too big by a factor of roughly 8. Everyone in the field was using it, because it was the best they had, and it was wrong, and because distance scales inversely with that number, every distance and every mass that depended on it was thrown off. When you correct Zwicky's 1933 result for the modern Hubble constant, that terrifying factor of 400 drops to something more like 50. Still enormous. Still completely impossible to explain with visible matter, but no longer the screaming 400-fold absurdity that practically demanded a revolution. A factor of 50 is the kind of thing a cautious scientist can tell himself might come out in the wash, might be the result of some error he has not spotted yet, might not require throwing out everything we thought we knew about what the universe is made of. The second reason for the doubt was deeper, and Zwicky himself had flagged it. The virial theorem only works on a system that has settled into a stable, balanced state. A system that is, in the technical language, relaxed and in equilibrium. Apply it to a system that is actually flying apart, or one that has not had time to settle, and it gives you nonsense. And a perfectly reasonable astronomer in the 1930s or 40s or 50s could look at the Coma cluster and ask a fair question. How do we know it is in equilibrium? What if these clusters are not stable, settled cities of galaxies at all, but loose, temporary associations that are in the middle of dispersing? If that were true, then the high velocities would not require any hidden mass to explain them. The galaxies would just be fast, because the cluster is coming apart, and the whole dark matter problem would evaporate. This was not a fringe objection. The Soviet-Armenian astrophysicist Viktor Ambartsumian, a major figure, argued exactly this in the 1950s, that the clusters were unstable and the velocity discrepancies were telling us the clusters were dissolving, not that there was invisible matter. At a conference in Santa Barbara in 1961 devoted to precisely this question, the room genuinely debated both possibilities, instability versus hidden mass, and both looked problematic. And there was no clean way to decide between them. The astronomer Geoffrey Burbidge reportedly said that which explanation you preferred came down, in the end, to a matter of taste. So when you put yourself in the shoes of an astronomer of that era, the silence starts to look less like a crime, and more like ordinary caution. Here is an extraordinary claim that most of the universe is invisible. It rests on a number that is probably inflated by a bad distance scale. It depends on an assumption, equilibrium, that may not even be true. And it comes from a man who has insulted half the people who might evaluate it. Of course they shelved it. Of course they said, interesting, unresolved, let us wait for better data. But here is the thing, and this is where I stop being fair to them, because there is a limit to how fair you can be. The discrepancy never went away. Every time anyone looked, with better data, with better methods, the missing mass was still there. And the field had a habit, a deep and repeated habit, of stumbling directly into the evidence for invisible matter and then finding a reason to look at something else. It happened more than once. It happened to more than one person. And once you see the pattern, the polite professional silence starts to look like something closer to a refusal. Because Zwicky was not even alone. 3 years after Zwicky's paper, in 1936, an American astronomer named Sinclair Smith published a study of a different galaxy cluster, the Virgo cluster, in the Astrophysical Journal, which was about as mainstream and respectable a venue as existed. Smith measured the motions of the galaxies in Virgo and found exactly the same kind of problem Zwicky had found in Coma. The cluster needed vastly more mass than its light could account for, something like 200 times more mass per galaxy than the standard estimate. Smith cited Zwicky directly. He noted the discrepancy. He cautiously suggested that maybe there was material between the galaxies, great clouds of low luminosity stuff distributed through the cluster that nobody could see. 2 independent measurements of 2 different clusters by 2 different astronomers, both finding the same impossible result. That is not a fluke. That is a signal. And here is the small, telling, infuriating detail that I think captures the whole era. When the great Edwin Hubble himself wrote his famous book, The Realm of the Nebulae, he acknowledged this mass discrepancy as a real and important problem. But the person he cited for it was Sinclair Smith, the respectable insider, and not Fritz Zwicky, the abrasive outsider who had found it first and named it. Even when the establishment engaged with the missing mass, it found a way to root around the man who had discovered it. I want to name that pattern clearly, because we are going to see it again before the night is over. There is a way that scientific communities handle an uncomfortable truth that is not censorship and is not conspiracy, and is in some ways more effective than either. They simply decline to make it central. They acknowledge it in a footnote. They cite the safe source instead of the dangerous one. They agree it is interesting and unresolved, and then they steer the bright young people toward problems that feel more tractable and more rewarding. No one ever has to say the uncomfortable thing out loud. No one ever has to take a stand against it. It just quietly never becomes the thing everyone is working on. And an idea that never becomes the thing everyone is working on can sit, fully published and fully correct, for 40 years. That is what happened to dark matter between 1933 and the early 1970s. It did not get refuted. It got orphaned. I want to slow down for a second, because I think the word orphaned is exactly right, and I do not want it to slide past you. We tend to imagine scientific suppression as something dramatic, a heretic silenced, a paper rejected, a career destroyed by powerful enemies. And there is some of that in this story. But the thing that actually kept dark matter in the dark for 40 years was not drama. It was the absence of drama. It was a room full of intelligent, decent, hard-working people who each, individually, made the entirely reasonable decision to work on something more promising, something more fundable, something less likely to make them look foolish, something that did not come attached to a man who had insulted them. No single one of those decisions was a crime. Not one of them would feel, from the inside, like looking away from the truth. It would feel like good judgment, like prudence, like focusing on what was tractable. And that is the most unsettling thing I have learned from this whole story. The thing that makes it more than a historical curiosity. The most effective way to bury a true and important idea is not to attack it. It is to find it slightly inconvenient, and to keep finding it slightly inconvenient, quietly, politely, for as long as it takes. No villain is required. The ordinary machinery of careful, sensible people is enough. And while it sat there, orphaned, the universe kept dropping more evidence directly into the laps of astronomers who kept finding reasons not to pick it up. Go back a year before Zwicky's paper to 1932. A Dutch astronomer named Jan Oort, one of the giants of the field, was studying the motions of stars in our own Milky Way, specifically how they bob up and down through the flat plane of the galactic disk. From the speed of that bobbing, he could calculate how much mass had to be present in the disk to produce the gravity pulling the stars back, and he found that the dynamical mass, the mass demanded by the motion, was larger than the mass he could see in stars. He inferred that there was roughly as much invisible matter in the local disk as visible matter. Now, as it happens, Oort's particular result here was later shown to be mostly mistaken, and most of what he was missing turned out to be ordinary faint stars and gas, rather than anything exotic. But the move he made, weighing the galaxy by its motion and finding more than the light could explain, was exactly the right move, and it was made 1 year before Zwicky. And it too led nowhere for decades. I should be honest with you about one thing here, because the clean version of the story likes to say that Zwicky invented the term dark matter out of nothing. And that is not quite right. The Dutch astronomer Jacobus Kapteyn had used the phrase in the sense of unseen mass among the stars back in the early 1920s. Oort was working in the same tradition. The general idea that there might be dark, unlit material scattered through space was floating around the astronomical community before Zwicky put pen to paper. What Zwicky did that was genuinely new, the thing that earns him the title even after you account for the people before him, was not the two words. It was the claim attached to them. Kapteyn and Oort were talking about a modest amount of dark material mixed in among the stars, a supplement to the visible universe. Zwicky was saying something far more radical. He was saying that the dark material was not a supplement at all. He was saying it was the main event, that it outweighed everything luminous by a factor of hundreds, that the visible universe was the minority report. Nobody before him had looked at the dark matter and said, that is most of what exists. He was the first to understand the scale of it, and being first to understand the scale of it is precisely what got him ignored, because a modest amount of dark material is a manageable idea, and a universe that is mostly invisible is not. Then go forward to 1939, to a young American astronomer named Horace Babcock, who for his doctoral thesis measured the rotation of the Andromeda galaxy, the great spiral that is our nearest large neighbor in space. Babcock measured how fast the outer parts of Andromeda were spinning, and he found something strange. The outer regions were moving far too fast. According to the ordinary laws of gravity, if most of a galaxy's mass is concentrated in its bright central bulge, the way most of the light is, then the outer stars should orbit more and more slowly the farther out you go, the same way Neptune crawls around the Sun far more slowly than Mercury does. That is what everyone expected. That is what Kepler's laws and Newton's gravity predict for a system where the mass is in the middle. That is not what Babcock saw. He saw the outer regions of Andromeda rotating with stubbornly high velocities, velocities that did not fall off the way they should. And those high outer velocities meant exactly one thing, the same thing Zwicky's high cluster velocities meant. There had to be a great deal of unseen mass out there in the dark outskirts of the galaxy, mass that was not glowing, providing the extra gravity needed to whip those outer stars around so fast. Babcock had the rotation curve of Andromeda in his hands in 1939. He had the fingerprint of dark matter sitting in his thesis data, and he did not see it as dark matter. He reached for other explanations. Maybe light was being absorbed in the outer regions. Maybe there were new dynamical effects nobody understood. And, critically, he did not connect his fast-spinning galaxy outskirts to Zwicky's fast-moving cluster galaxies. The two phenomena were the same phenomenon, the same invisible mass showing up in two different arenas, and nobody put them together. The connection was just sitting there, unmade, for another 30 years. I find this genuinely hard to think about, and I want to be honest with you that I do, because it is so easy to be smug about it in hindsight. Of course it was dark matter, we want to say. How did they miss it? But that is the trap. They did not miss it because they were stupid. Babcock and Oort and Zwicky and Smith were not stupid people. They missed it, or half saw it and turned away, because seeing it clearly would have required accepting something that the entire architecture of physics and astronomy was built to deny, which is that the universe is mostly made of stuff that does not interact with light at all. That is not a small revision. That is a demotion of everything we can see to the status of a minor impurity. It is the kind of idea that a sane, careful, well-trained scientist resists not because of any single flaw in the evidence, but because the conclusion is so large that the mind looks for any available exit. And for 40 years, the mind found exits. The exits ran out in the 1970s. And they ran out because of a woman who chose her research problem specifically because she thought no one would bother her about it. Her name was Vera Rubin, and if Zwicky is the abrasive genius nobody wanted to deal with, Rubin is almost his opposite in temperament and identical in fate, which is to say she too spent years being quietly overlooked, though for very different reasons. Rubin was born in 1928. She was a woman trying to build a career in observational astronomy in an era when the field was almost entirely closed to women, when she was, at various points, not permitted to use the telescopes that the men used as a matter of routine. She became, in fact, the first woman officially allowed to observe at the great 200-inch telescope on Palomar Mountain, the same mountain Zwicky worked on. And the story goes that when she arrived there was not even a women's restroom for her to use. The version Rubin herself told is that she looked at the door of the men's room, with its little figure, went back to her room, cut a paper skirt out of a piece of paper and taped it onto the figure on the door and announced that now there was a women's room. She built her own welcome out of paper because the most powerful telescope on Earth had been designed on the assumption that no woman would ever use it. Keep that image in mind, because it tells you something about who gets to find the truths and who gets remembered for them. Rubin made a deliberate, strategic decision early in her career. She had been burned before by working on controversial, high-profile topics that drew aggressive attention and aggressive men. So she chose, on purpose, a problem that she thought was interesting enough to matter, but boring enough that nobody would crowd her or fight her for it. She decided to measure, very carefully, the rotation of spiral galaxies, how fast the stars and gas in a galaxy go around the center, as a function of how far out they are. It was, she thought, a quiet, safe, unglamorous problem. She picked it precisely so that she could work in peace. She had no idea she was walking straight into the thing Zwicky had found in 1933. She had no idea she was about to be the person who finally forced the entire field to stop looking away. She worked with an instrument builder named Kent Ford, who had constructed an extraordinarily sensitive spectrograph, a device that could measure the velocities of faint gas clouds in distant galaxies with a precision that earlier astronomers like Babcock could only have dreamed of. Together, Rubin and Ford pointed this instrument at the Andromeda Galaxy, the very same galaxy Babcock had studied 30 years earlier, and they measured its rotation in fine detail, going farther out from the center than anyone had managed before. The landmark paper came out in 1970 in the Astrophysical Journal, Volume 159, page 379, by V.C., Rubin and W.K. Ford. What they expected to find was the textbook picture. The rotation speed should rise as you move out from the center, reach a peak somewhere in the bright inner regions where most of the visible mass is, and then fall off, gently, the way the planets in our solar system orbit more slowly the farther they are from the Sun. That falling off is called a Keplerian decline, and it is exactly what you get when the mass is concentrated in the middle and the light traces the mass. Every reasonable person expected the rotation curve to come down on the outside. It did not come down. It went flat. As Rubin and Ford measured the velocities farther and farther out from Andromeda's center, into the dim regions far beyond the bright glow of the galaxy's disk, the rotation speed simply refused to drop. Stars and gas way out in the faint outskirts were orbiting the center just about as fast as material much closer in. The curve, plotted out, did not arc up and then down like a fountain. It rose and then ran straight across, flat, like a tabletop, out to the very edge of where they could measure. There is only one way that happens. For the outer material to be orbiting that fast without flying off into space, there has to be a great deal of additional mass out there, far beyond the visible edge of the galaxy, in a vast unseen halo, providing the extra gravity. The visible galaxy, the part that glows, the part in every photograph you have ever seen of a spiral galaxy, turns out to be sitting inside a much larger, much heavier sphere of completely invisible matter. The light is just the bright center of something enormous and dark. Rubin would later put the conclusion in language that does not hedge at all. She wrote that the conclusion is inescapable, that non-luminous matter exists beyond the optical galaxy. Inescapable, not suggested, not possible, not worth considering. Inescapable, and then she did the thing that turned one strange result into a revolution. She did not stop at Andromeda. Through the rest of the 1970s, she and Ford and their collaborators measured galaxy after galaxy after galaxy, 21 spiral galaxies by the time they published their major survey in 1980, and the rotation curves came back flat, every single time. Not most of the time, every time, galaxy after galaxy, all of them sitting in invisible halos far more massive than anything that's shown. As one astronomer put it, the curves kept coming, and they were all flat. There was no longer any wiggling out of it. You could explain away one weird galaxy. You could not explain away 21. You could not explain away the universe. But here is the second twist, and it is the one that the clean version of the story almost always leaves out, and I think it is more honest and more haunting than the myth, so I am going to give it to you straight. Vera Rubin did not set out to confirm Fritz Zwicky. She did not, at the time, even connect what she was doing to what he had done. In an oral history interview she gave later in her life, archived by the American Institute of Physics, she was asked directly whether Zwicky's work was on her mind, and she was completely candid. She said that, to be honest, it was not prominent in her thinking at all. She said that on some level everyone knew about Zwicky's work, but that his original paper was in German and she had never read it. And then she said something that I find quietly devastating. She said that at one point she went back and looked up all the references to Zwicky's early work in the rotation curve literature, and none of them, including her own, had cited it. The first time the modern field really linked the galaxy rotation curves back to Zwicky's 1933 cluster measurement was in a review article in 1979 written by Sandra Faber and Jay Gallagher, decades after the fact. That review is worth pausing on, because it is the moment the scattered pieces finally got assembled into one picture. Faber and Gallagher gathered up everything: the cluster velocities, the flat rotation curves, the radio measurements, the mass-to-light ratios, all the separate threads that had been accumulating for almost half a century, and they laid them side by side and made the case that they were all measuring the same thing, that the missing mass in clusters and the missing mass in galaxies were one phenomenon, and that the evidence for it had become, in their judgment, compelling. It was the review that flipped the consensus. Before it, dark matter was a collection of unexplained anomalies that smart people mostly avoided. After it, dark matter was a problem the whole field had to take seriously. And notice what it took. It did not take a new measurement. It took someone finally willing to stand up and say that the anomalies everyone had been politely ignoring for decades in journal after journal were not separate small puzzles, but one enormous fact that had been staring the field in the face the entire time. The evidence had all been there. What had been missing was the willingness to add it up out loud. Think about what that means. The two greatest pieces of evidence for dark matter in the 20th century, Zwicky's clusters in the 1930s and Rubin's rotation curves in the 1970s, were not a relay race. They were not one scientist handing a baton to the next. They were two completely independent people, 4 decades apart, walking separately into the same impossible fact. Neither of them initially aware that they were looking at the same thing. The connection between them was made afterward, in hindsight, by historians and review writers stitching the story together once the conclusion had become impossible to deny. And to me that is so much stranger and so much more unsettling than the tidy myth, because it means this was not one stubborn genius being ignored. It means the universe kept presenting the same evidence over and over, in different forms, to different people, across 40 years, and each time the people who found it either looked away or did not realize what they had. The dark matter did not need a prophet. It just needed enough honest measurements to pile up until the weight of them broke through. The reason we believe in it now is not that we finally listened to Zwicky. It is that reality simply would not stop saying the same thing. There is a coda to Rubin's part of this that I cannot leave out, because it rhymes with Zwicky's in a way that is almost too neat to be real. To her enormous credit, once Rubin understood the history, she became one of the most generous narrators of Zwicky's priority that the field has had. In her own later writing, including an essay she wrote for the magazine Physics Today in 1996, she told the story of his 1933 discovery and gave him his due, the credit her own generation had failed to give him at the time. She refused to let him stay invisible, even though staying silent would have flattered her own legacy. And then, the field did to her something not entirely unlike what it had done to him. Vera Rubin, who provided the observational evidence that finally forced dark matter into the center of cosmology, who changed our picture of the universe as profoundly as almost anyone in the 20th century, was never awarded the Nobel Prize. Year after year her name was raised, and year after year it was passed over, and many physicists considered it one of the clearest injustices in the history of the award. She died in December of 2016 at the age of 88 without it. So there is your pattern, and you can count it. Zwicky, who found the invisible mass in clusters, marginalized and written out of the textbooks. Sinclair Smith, who confirmed it in Virgo, dead young just a few years after his discovery, barely remembered. Rubin, who proved it lived inside every spiral galaxy, denied the field's highest honor to the end of her life. There is something about this particular truth, the truth that most of the universe is invisible, that seems to make the people who carry it invisible too. By the early 1980s, the case became overwhelming. helped along by yet another line of evidence that I have to mention, because it closes a small loophole that even Rubin's work had left open. There had been a quiet objection to the optical rotation curves, which was that they did not quite extend far enough out, that the strongest evidence for the dark halo lay just beyond where Rubin's optical measurements could reach. That loophole was closed by radio astronomers who could trace the cold hydrogen gas in galaxies using its emission at a wavelength of 21 centimeters, far beyond the edge of the visible starlight. Astronomers like Morten Roberts and a young Dutch researcher named Albert Bosma, whose 1978 thesis measured the extended rotation of 25 galaxies of every type, pushed the rotation curves out into the deep dark outskirts using radio data, and the curves stayed flat out there too, flatter and farther than anyone could dismiss. With that, the debate was effectively over. Dark matter, the thing Zwicky had named in 1933, was real. It was everywhere. And it dominated. I want to close one loop here before it festers, because some of you have been waiting for it. What happened to Zwicky's factor of 400? If the number was that inflated, did the dark matter maybe just shrink away to nothing once the errors were cleaned up? It is a fair question, and the answer is the most important part of the whole reconciliation, so follow it carefully. The factor of 400 came down in 2 steps. The first step was the Hubble constant correction, which dropped it to roughly 50. The second step came from the 1960s and 70s, when a new kind of astronomy, X-ray astronomy, became possible. And satellites looking at the sky in X-rays discovered something nobody had counted. The space between the galaxies in a cluster like Coma is not empty. It is filled with an enormous quantity of gas, heated to tens of millions of degrees, glowing in X-rays, invisible to ordinary optical telescopes. And this gas, it turns out, outweighs all the stars in all the galaxies of the cluster by a factor of 3 or 4. For a moment, this looked like the escape hatch. Here, finally, was a huge reservoir of mass that Zwicky had missed. Ordinary matter, normal matter, hiding in plain sight as hot invisible gas. Maybe that was the missing mass. Maybe there was no need for anything exotic at all. It was not the escape hatch. When you add up everything, the stars and the hot gas together, every scrap of ordinary matter the cluster contains, and you compare it to the total mass that gravity demands, you still come up short by a factor of about 5 or 6. The hot gas accounted for some of what Zwicky was missing. It did not account for most of it. The number went from 400 to 50 to 5 or 6, and there it stopped, and it has not moved since, because that final factor of 5 or 6 is not an error. It is the dark matter. Cleaning up every mistake Zwicky made, finding every bit of ordinary matter he could not see, did not make the problem disappear. It made the problem precise. And a precise problem that will not go away is far more frightening than a sloppy one that might. And you would think that this is the happy ending. The outsider was right. The evidence won. The invisible majority of the universe was finally formally accepted into the textbooks. Vindication. Except that being right is not the same thing as understanding. And this is the exact moment where the real horror of the story begins. Because the field had now confirmed, beyond any reasonable doubt, that about 85% of all the matter in the universe is something we cannot see. And having confirmed that it exists, having proven it is there with overwhelming gravitational evidence from clusters and rotation curves and more, the field then turned to the obvious next question. Fine, it is real. What is it? And 90 years after Zwicky, that question does not have an answer. Not a partial answer, not a leading candidate that is almost confirmed. Nothing. Stop and weigh that against the rest of what physics has accomplished in the same span of time. In the 90 years since Zwicky published his cluster paper, we split the atom and built the bomb. We decoded the structure of DNA and learned to read and edit the genome. We put human beings on the moon. We built machines that fit in your pocket and hold the sum of human knowledge. We photographed a black hole. We caught the ripples in space-time from two black holes colliding more than 1 billion light-years away, stretching our instruments by a fraction of the width of a proton, and we measured it. The reach of 20th and 21st century physics is staggering, almost beyond comprehension. And across that exact same period, facing the simple question of what the majority of the universe is made of, we have produced not one confirmed fact about its nature. We know it is there. We have known since 1933, and we have not advanced a single step toward knowing what it is. There is no other problem in modern science quite like it. A thing so abundant, so close, so thoroughly confirmed to exist, and so completely opaque to every method we can throw at it. Let me be precise about what we actually know, because the precision is where the dread lives. We know how much dark matter there is, very accurately. The best measurements we have from the European Space Agency's Planck satellite, which mapped the faint afterglow of the Big Bang in exquisite detail, give us a breakdown of everything in the universe. Ordinary matter, the kind of matter that you and I and the stars and the planets are made of, the protons and neutrons and electrons, the entire periodic table, everything that has ever been seen or touched or detected in any laboratory in human history, makes up about 4.9% of the total content of the universe. Dark matter makes up about 26.8%, and the rest, about 68%, is something called dark energy, which is a separate mystery that we will set aside in a moment, because conflating it with dark matter is one of the most common mistakes made about this whole subject, and I do not want you to make it. And I want you to understand that this number, the 26.8%, does not come from Zwicky's clusters or from Rubin's rotation curves at all. It comes from a completely different direction, which is what makes it so hard to argue with. When the Planck satellite mapped the cosmic microwave background, the faint heat left over from the Big Bang, it was looking at a photograph of the universe as it was about 380,000 years after it began, long before there were any stars or galaxies, and imprinted on that ancient light is a pattern of faint ripples, slightly hotter and slightly cooler patches that are the frozen echoes of sound waves rolling through the hot plasma of the infant universe. The exact sizes and spacings of those ripples depend very sensitively on how much ordinary matter and how much dark matter were present to push and pull on that plasma. The two kinds of matter leave different fingerprints, because dark matter does not feel the pressure of light the way ordinary matter does, and so they shape the ripples differently. When you measure the pattern and work backward to figure out what mix of matter would produce exactly those ripples, you get the same answer, about 5 times as much dark matter as ordinary matter. The clusters say it, the rotation curves say it, the lensing says it, and the oldest light in the universe, emitted before a single star existed, says it too, independently, from physics that has nothing to do with any of the others. When 4 completely separate lines of evidence, using completely different physics, all converge on the same impossible number, you are no longer looking at a mistake. You are looking at a fact about the world. Focus just on the matter, the stuff with mass that clumps together and pulls on things. Of all the matter in the universe, the ordinary kind, our kind, is about 15%. The dark kind is about 85%. The ratio is roughly 5.5 to 1. For every kilogram of normal matter in existence, there are about 5.5 kilograms of something else. Now hold that next to the other number. We can measure how much of it there is to within 1% or 2%, and we have absolutely no idea what it is. We have measured the abundance of a substance to extraordinary precision while remaining completely ignorant of its nature. Imagine knowing exactly how much water is in a glass, down to the milliliter, while having no idea whatsoever that the substance is water, or what water is, or what it is made of, or whether it is even a liquid. That is the position modern physics is in with respect to most of the matter in the universe. We have weighed the invisible majority of reality to the decimal point, and we cannot name it. And it is not for lack of trying. The trying has been enormous, and it has been failing for decades, and the failure is itself a kind of unspoken scandal. For most of the last 40 years, the leading suspect was a hypothetical particle nicknamed the WIMP, which stands for Weakly Interacting Massive Particle. The idea was elegant, and the theory was beautiful. The WIMP would be a heavy particle, something like 100 to 1,000 times the mass of a proton, that barely interacts with ordinary matter, interacting only through gravity and through the weak nuclear force. If such particles were created in the right abundance in the early universe, they would naturally produce exactly the amount of dark matter we observe. This near miracle of the numbers working out was so compelling that physicists gave it a name, the WIMP miracle, and an entire generation of experiments was built to catch one. The way you catch a WIMP in theory is that you take a large amount of some very pure, very dense material. You put it deep underground to shield it from cosmic rays and other interference, and you wait. Because the Earth is constantly plowing through the halo of dark matter surrounding our galaxy, dark matter particles should be streaming through your detector all the time. Billions of them passing through every second, almost all of them ignoring the ordinary matter completely. But every once in a great while, by pure chance, one of them should happen to strike the nucleus of an atom in your detector and give it a tiny recoil, a faint flash of light, a small kick of energy that your instruments could register. Build a big enough, clean enough, sensitive enough detector, wait long enough, and you should see those rare flashes. You should catch the invisible majority of the universe in the act of brushing against the visible minority. So they built the detectors, enormous tanks of ultra-pure liquid xenon, kept colder than the surface of any planet, buried more than a mile underground in old mines to shield them from everything except the dark matter itself. The depth matters, and the reason is its own kind of poetry. At the surface, you are constantly being struck by cosmic rays and stray radiation that would drown any dark matter signal in noise, so they put the detector under a mile of solid rock, which blocks nearly everything ordinary, while the dark matter, which ignores rock entirely, sails straight down through the mountain and into the tank as though the mile of stone were not there. The xenon itself has to be purified to a degree that is hard to even describe, scrubbed of any radioactive contamination down to a few atoms in an unimaginable sea of other atoms, because a single stray decay would look like the signal they are hunting. And then, having built this monument of cold and silence and purity a mile inside the Earth, they do the one thing the whole apparatus is really for. They wait. They sit in the dark, watching 10 tons of liquid xenon, waiting for the universe to flick a single atom hard enough to notice. It is one of the most patient acts in the history of science, and so far the universe has refused to flick. The current champion of these experiments is called ELS, short for LUX Zeppelin, a 10-ton tank of liquid xenon operating nearly a mile down in a former gold mine in South Dakota. It is the most sensitive dark matter detector ever constructed, the product of 250 scientists across dozens of institutions, representing decades of cumulative effort and enormous expense. In December of 2025, the ELS collaboration reported the results of analyzing 417 days of data, the largest dataset ever collected in the search for dark matter. And what they found, after all of that, after the mile of rock and the tons of xenon and the decades of work, was nothing. No WIMPs. They set the most stringent limits in the history of the field, ruling out vast new swaths of the possible properties a WIMP could have, and they did it by detecting, definitively, the absence of the thing they were built to find. Their predecessors had done the same. Xenon in Italy, deep under a mountain, Panda X in China. The same story, told again and again in ever more sensitive instruments. Tighter and tighter limits. Nothing and nothing and nothing. And I want you to understand the scale of the disappointment, because it is not the disappointment of one failed experiment. It is the disappointment of an entire scientific generation. The WIMP hypothesis dominated the search for dark matter for the better part of 40 years. Careers were built on it. Hundreds of millions of dollars were spent on it. The detectors grew from kilograms to tons. From tons to tens of tons, each generation 1,000 times more sensitive than the last. Each one confidently expected to be the one that finally caught a signal. There were even a few false alarms over the years, faint hints that flickered and then vanished under scrutiny. And as the detectors swept across the range of masses and interaction strengths, where theory said the WIMP simply had to be, they found it empty. They have now ruled out the great majority of the natural hiding places the WIMP was supposed to occupy. The beautiful, elegant, almost miraculous particle that was supposed to be the answer has been hunted across nearly the entire territory where it was predicted to live, and it is not there. The theory is not quite dead, because theories like this are very hard to kill completely. But the people who built their lives around it are now, many of them, quietly admitting that the universe did not do them the courtesy of being simple. The experiments have now become so sensitive that they have run into a wall that I find almost poetic in how it mocks the entire enterprise. The ELS detector, in its hunt for dark matter, has become sensitive enough that it has started detecting neutrinos coming from the core of the sun. Neutrinos are a known particle, a real, ordinary, well-understood part of physics, and they produce a signal in the detector that looks maddeningly similar to what a dark matter particle would produce. This is called the neutrino fog, and it means that as the experiments push to ever greater sensitivity in search of the WIMP, they are beginning to be drowned out by a background of ordinary neutrinos that they cannot fully distinguish from the signal they actually want. The search for the invisible is being blinded by the faint glow of the known. When the WIMP began to look exhausted, the field did not give up. It turned to a completely different candidate, a particle called the axion, which is in many ways the opposite of the WIMP. Where the WIMP is heavy, the axion would be almost unimaginably light, perhaps a trillionth of the mass of an electron. It was not originally invented to explain dark matter at all. It fell out of an attempt to fix an unrelated problem in the theory of the strong nuclear force, and it was named by the physicist Frank Wilczek after a brand of laundry detergent because he said it cleaned up a problem. But the axion has a property that makes it detectable in principle. In a strong magnetic field, an axion can occasionally convert into a faint photon, a tiny whisper of microwave radiation at a frequency that depends on its mass. So physicists built an instrument to listen for that whisper. The leading version is called ADMX, the Axion Dark Matter Experiment, and it is essentially a very cold, very quiet, exquisitely tuned radio receiver sitting inside a powerful magnet slowly scanning across frequencies, listening for the sound of dark matter turning into light. It has been listening for years. It has set the best limits in the world on where the axion can be hiding. And it has heard nothing. Just like the xenon tanks, just like Zwicky's colleagues walking past his paper, the most sensitive instrument ever built to hear the dark matter has, so far, returned only silence. And as the two front-runners have come up empty, the list of suspects has not shrunk. It has exploded. When you cannot find the thing you are looking for in the obvious places, you start proposing that it might be something stranger, and the modern catalogue of dark matter candidates reads like the inventory of a field that has run out of confident answers. Maybe it is sterile neutrinos, a hypothetical heavier cousin of the ordinary neutrino. Maybe it is primordial black holes formed in the first instance of the Big Bang and scattered through space ever since. Maybe it is a whole hidden sector of physics, a dark photon, a dark force, an entire shadow family of particles that interacts with itself and ignores us almost completely. Maybe it is something with no name yet at all. Each of these is a serious proposal by serious people, and that is exactly the point. When a field has one good candidate, it has a theory. When a field has a dozen candidates spanning 80 orders of magnitude in possible mass, from things lighter than a neutrino to things as heavy as a mountain, it does not have a theory. It has a confession. The proliferation of candidates is not a sign of progress. It is a sign that 90 years in, we are still guessing, and we know we are still guessing, and the guesses are getting wilder, not narrower. After decades of this, some of the most serious people in the field have started saying, out loud and in print, the thing that you are not supposed to say. In a piece in Scientific American in 2024, the theoretical physicist Tracy Slattier of MIT and the particle physicist Tim Tate of the University of California wrote that they have been trying to detect dark matter for decades, to no avail, and that the field is starting to grapple with the sobering possibility that we may never actually nail down what dark matter is. They wrote that in the early days of the hunt, that idea would have seemed absurd. It does not seem absurd anymore, and there is a smaller, more contrarian camp that goes further, and I want to give them their due, because intellectual honesty demands it, and because they might, just possibly, be right. The astronomer, Stacy McGaugh, when asked why every single dark matter search keeps coming up empty, has given an answer that runs directly against the entire mainstream of the field. His answer is that it is possible. The stuff simply is not there. Which brings us to the alternative, the idea that has lurked at the edges of this whole story for 40 years. The idea that maybe there is no invisible matter at all, and that what we are seeing is instead a sign that our laws of gravity are wrong. In 1983, an Israeli physicist named Mordechai Milgrom proposed something heretical. He suggested that instead of adding vast amounts of invisible matter to make the equations work, we should consider modifying the equations themselves. Specifically, he proposed that Newton's law of gravity, the law that works so beautifully in the solar system and on Earth, might break down at the extremely low accelerations that exist in the faint outskirts of galaxies. Below a certain tiny threshold of acceleration, gravity might be a little stronger than Newton says. He called this idea modified Newtonian dynamics, or MOND, and with that one adjustment, without any dark matter at all, MOND reproduces the flat rotation curves of galaxies with uncanny, almost suspicious accuracy. It predicts the detailed shapes of galaxy rotation curves, in many cases better than dark matter models do, and it does it with essentially no free parameters to tune. At the scale of individual galaxies, MOND works disturbingly well. Let me give you the single most uncomfortable example. because it is the one the dark matter camp has the hardest time explaining. There is a tight empirical relationship in spiral galaxies called the Tully-Fisher relation, which connects how bright a galaxy is to how fast it rotates. The faster a galaxy spins, the more luminous it is, and the relationship is astonishingly precise, far more precise than it has any right to be. Here is the problem. The rotation speed is supposedly set mostly by the dark matter halo, the invisible part. The luminosity is set by the stars, the visible part. So why on earth should the amount of invisible matter and the amount of visible matter be locked together in such a tight, lawful relationship across thousands of galaxies? If dark matter is just some particle that fell into a halo, why does it know so precisely how many stars formed inside it? MOND predicts this relationship effortlessly. Because in MOND there is no separate dark component to coordinate, the gravity simply follows the visible matter. Dark matter has to explain the tightness of that relationship as a kind of cosmic coincidence, a conspiracy between the seen and the unseen. And I have read a lot of attempts to explain that coincidence away, and I will be honest with you, none of them fully satisfies me. That is the strongest card MOND holds, and it is a real card, and anyone who tells you the dark matter picture is airtight is not being straight with you. I want to be honest with you about MOND, because the temptation here is to either dismiss it as crackpottery or to embrace it as the suppressed truth, and neither of those is correct. MOND is not crackpottery. It is a serious idea taken seriously by serious physicists, and the fact that it describes individual galaxies so well is a genuine, unexplained, embarrassing success that the dark matter camp has never fully accounted for. If dark matter is real and is just some particle sitting in a halo, why should the visible matter and the dark matter conspire to produce the tight, regular, almost lawful relationships that MOND describes so well? That is a real question, and it does not have a comfortable answer. But MOND has its own catastrophic problem, and the problem is, of all things, galaxy clusters. The very objects Zwicky started with. When you apply MOND to a cluster like Coma, it does not quite work. It reduces the discrepancy, but it does not eliminate it. There is still missing mass left over that MOND cannot account for. The theory that so beautifully explains away the dark matter in individual galaxies cannot explain away the dark matter in the clusters, where the whole story began. There is a strange symmetry in that, almost a cruel one. The idea that might save us from the invisible majority fails precisely at the place Zwicky first found it. And then there is the single most powerful piece of evidence in this entire debate, an object that more than anything else has kept the mainstream firmly on the side of real, particle dark matter. It is called the bullet cluster, and it is what happens when two galaxy clusters collide head-on. When two clusters smash into each other, something revealing occurs. The clusters are made of three components. There are the galaxies themselves, which are mostly empty space and so pass right through each other like two swarms of bees flying through one another. There is the hot gas between the galaxies, which actually makes up most of the ordinary, visible matter in a cluster, and this gas, being a fluid, collides and slows down and gets left behind in the middle, glowing in X-rays. And then there is whatever provides the extra gravity, the dark matter, if it exists. In the bullet cluster, astronomers used a technique called gravitational lensing, measuring how the cluster's gravity bends the light of more distant galaxies behind it, to map out where the mass actually is. And I need you to catch what that means, because it is one of those moments where the story folds back on itself. Gravitational lensing, using the bending of light by a massive object to weigh that object, including its dark matter, is the exact technique Fritz Zwicky proposed in 1937, in the teeth of Einstein's own doubt that it would ever be practical. The single most powerful proof of dark matter ever produced was generated by the very tool that dark matter's discoverer invented to look for it almost 70 years earlier. He did not just find the thing, he handed the future the instrument it would use to confirm it, and then he died before anyone picked the instrument up. And what they found is the closest thing to a smoking gun this field has ever produced. The center of mass, the place where most of the gravity is, did not stay with the hot gas in the middle. It passed straight through, along with the galaxies, and ended up clearly separated, spatially offset, from the bulk of the visible ordinary matter. In a paper from 2006, with the blunt and confident title, A Direct Empirical Proof of the Existence of Dark Matter, a team led by Douglas Clow reported that the mass and the visible matter in the bullet cluster are separated at a statistical significance of 8 sigma, which in physics is about as certain gets. And they argued that this separation cannot be explained by modifying the law of gravity, because a modified gravity law would keep the extra gravity attached to the visible matter, where the visible matter is. The only way to get the gravity to physically separate from the glowing matter and travel with the invisible part is if there really is an invisible part, a substance, a thing, that passed through the collision unimpeded while the ordinary gas got stuck. Now, in the interest of the honesty this subject demands, the MOND camp has fought back even on the bullet cluster, arguing that the offset can be partly accommodated with some additional unseen mass, perhaps in the form of neutrinos, and the argument genuinely continues in the literature. But if you ask me where the weight of the evidence sits, and I have spent more time than is healthy reading both sides of this, it sits with real dark matter, with an actual substance, and the bullet cluster is the main reason. Something passed through that collision that was not the gas and was not the light. Something with mass and gravity that does not interact with ordinary matter the way ordinary matter interacts with itself. Whatever that something is, it is the thing Zwicky found. So here is where we actually stand, 90 years after a difficult Swiss astronomer ran some numbers on 8 galaxies. Dark matter is real. The gravitational evidence is overwhelming and comes from a dozen independent directions, from clusters, from rotation curves, from gravitational lensing, from the cosmic microwave background, from the very pattern of how galaxies are distributed across the sky. It outweighs everything we can see by more than 5 to 1. And we cannot detect it directly, we cannot make it in a laboratory, we cannot say what particle it is. Our most sensitive experiments find only its absence. Our most beautiful alternative theory works for galaxies but fails for clusters. And some of the best physicists alive are beginning to admit that we may never know. I want to stop here and ask you a question that I think you should sit with, because the answer is part of the story. How is it possible that you have lived your entire life on a planet whose own scientists have known, for half a century, that the universe is mostly made of something they cannot identify, and yet this fact has never landed on you with anything like the weight it deserves? You may have heard the phrase dark matter. It may have drifted past you in a documentary, a headline, a half-remembered science class. But did anyone ever stop you and say, plainly, that the overwhelming majority of the matter in existence is a complete unknown, that we are a rounding error in our own universe, that the people whose job it is to understand reality have hit a wall they have not moved in 50 years? Almost certainly not. And the reason is not a conspiracy. There is no committee suppressing this. The reason is quieter and, I think, more revealing. It is that an admission of this size is uncomfortable for the institutions that are supposed to be the authorities on reality. It is far more reassuring, in a textbook, in a press release, in a classroom, to present the universe as basically understood, with a few details left to fill in, than to lead with the truth, which is that we do not know what most of it is. The confident version is better for funding, better for morale, better for the public image of a science that has its house in order. So the discomfort gets smoothed over. The not knowing gets buried in a single phrase, dark matter, that sounds like a label for something understood rather than a placeholder for total ignorance. You were not lied to. You were just never made to feel the size of the whole. And once you do feel it, you cannot stop feeling it. I told you earlier that the way Zwicky was treated is, in its own quiet way, almost as disturbing as the thing he found. And I want to return to that now, because there is an irony running underneath this entire story that I cannot stop turning over in my mind. Fritz Zwicky discovered that most of the universe is invisible, and then his own field, slowly and without ever quite admitting it was doing so, made him invisible too. By the end of his career, the marginalization had become almost physical. Zwicky was forced into retirement in 1966. He was barred from the great telescopes on Mount Wilson and Palomar, the instruments he had used for his life's work, following a quarrel with a more favored colleague, and he raged about it to anyone who would listen, complaining that the spherical bastards had thrown him off the 200-inch telescope and made up a special rule to do it. In 1968, he lost his office and was given space in the basement of the Celtic Physics building, in the engine room, where he continued into his old age the painstaking work of cataloguing galaxies. There is a description in one biography of how, if you went looking for his name in the official histories of the great observatories or in the astronomy textbooks of the era, you would look in vain. The man who had named dark matter, who had done foundational work on some of the most important objects in the universe, had been written almost entirely out of the record of the field he had transformed. And here is the part that makes it a tragedy rather than just an injustice. Because a tragedy requires that the hero participate in his own downfall, and Zwicky did. In 1971, he published, at his own expense, a catalogue of compact galaxies, and in the introduction to it, instead of letting the work speak, he used the space to launch one more furious attack on his colleagues. He called them sycophants and toadies. He accused the establishment astronomers of being useless, of stealing ideas, of running the field like a closed shop that crushed outsiders. Some of it, frankly, was true. He had been wronged, and his anger was not baseless. But imagine being a young astronomer in 1971, opening a scientific catalogue and finding the author screaming at you from the introduction. You do not absorb the science, you close the book. Zwicky had spent decades being marginalized by a field that did not want to deal with him, and his response was to make himself even harder to deal with, which gave the field even more reason to look away, which made him angrier, in a spiral that ran all the way to the end of his life. The invisible mass of astronomy was, in part, hiding himself. He poured his genius and his bitterness into the same vessel, and the bitterness kept poisoning the genius, and he could not stop, and it cost him the recognition he had earned 100 times over. And I have not even told you the rest of what he did, because the rest of what he did makes the erasure even harder to stomach. The dark matter discovery was not a lucky guess from a man with one good idea. It came from one of the most fertile scientific minds of the 20th century, and almost everything he touched turned out, decades later, to be right. In 1934, working with the very Walter Baade, who would later become his enemy, Zwicky coined another word that you know. Supernova. The two of them proposed that certain enormous stellar explosions, which they named supernovae, represented the collapse of ordinary stars into an entirely new kind of object. A star made almost entirely of neutrons, packed to unimaginable density. The neutron itself had only been discovered 2 years earlier. Zwicky and Baard were proposing the existence of neutron stars in 1934 as a theoretical idea so far ahead of its time that it would take 33 years until the discovery of pulsars in 1967 for them to be confirmed to exist. And when that confirmation finally came, Zwicky's role in predicting it was, once again, routinely overlooked. The pattern had shown up almost immediately when Robert Oppenheimer, who would later run the Manhattan Project, published with his student George Volkoff the detailed physics of how a collapsing star could form a neutron star. In 1939, they did not cite Zwicky's prediction of the very objects they were calculating. Even though Oppenheimer's office at Caltech was practically down the corridor, the man had predicted neutron stars 5 years earlier, and the foundational paper working out their physics acted as though he had never spoken. He complained about that too, bitterly, telling a young astronomer that he had told those no-good spherical bastards in 1933 that supernovae make neutron stars, and now they had found their pulsars, and nobody gave him the credit. In 1937, he published a paper proposing that entire galaxies could act as gravitational lenses, bending the light of more distant objects behind them, and he argued, against Einstein's own pessimism on the subject, that this effect could be used to weigh galaxies, including their dark matter, and that detecting it was practically a certainty. The first gravitational lens was discovered in 1979, 42 years later. And gravitational lensing is, as you just heard, the exact technique that produced the smoking gun evidence for dark matter in the bullet cluster. Zwicky proposed the tool that would one day confirm his own discovery, and he proposed it 4 decades before anyone could use it. He personally discovered around 120 supernovae over his career, a record for a single human being that stood until 2009, found by painstakingly comparing photographic plates by eye, sometimes wearing an eye patch to rest one eye, which made his students think of him as a kind of pirate. I want you to picture the actual labor of that, because it tells you what kind of mind he had underneath the rage. A supernova is the explosive death of a star, a single star briefly blazing as bright as an entire galaxy of billions of stars, and then fading. To find one, Zwicky would photograph the same patch of sky on different nights, producing glass plates, each holding the faint pinpricks of thousands upon thousands of galaxies, and then he would compare them, point by point, looking for the one new dot that had not been there before, the one star out of billions that had chosen that week to detonate. It is mind-numbing, eye-destroying work, the search for a single changed point of light in a field of countless unchanged ones. And he did it, by hand, by eye, for years, and he was better at it than anyone alive. The same man who could not sit through a committee meeting without insulting someone had the patience to hunt single dying stars across photographic plates for decades. The contradiction is the man. He had no patience at all for people, and infinite patience for the universe. He compiled vast catalogues of galaxies and clusters that became essential reference works. He helped found a rocket company and held more than 50 patents in jet propulsion, and for that work the United States awarded him the Presidential Medal of Freedom in 1949, making him, reportedly, the first foreign national to receive it. He invented an entire method of thinking, which he called morphological analysis, a systematic way of mapping out every possible solution to a problem by laying its dimensions in a grid he called the morphological box, and it is still taught and used in engineering and strategy to this day. When the Royal Astronomical Society of London invited him to give the prestigious Halley Lecture in 1948, an honour reserved for the field's most distinguished figures, he used the occasion not to speak about stars or galaxies, as expected, but to lecture the assembled British astronomical establishment about his morphological method, baffling much of the audience, because of course he did. And there is one more story that I think tells you everything about the gap between what he did and what he was given credit for. In 1957, an experiment Zwicky was involved in, using a small rocket charge, is believed to have flung a metal pellet fast enough to escape the Earth's gravity entirely and enter into orbit around the Sun, which would make it the first human-made object ever to leave Earth's gravitational grip. It happened, by some accounts, before the launch of Sputnik, the first man-made thing to escape the Earth, and almost nobody has ever heard of it. And the man behind it spent his old age in a basement, cataloguing galaxies, raging at the people who had written him out of the story. This was not a marginal figure who got lucky once. This was a titan, working at the absolute frontier of multiple fields at once, being right, over and over, decades before anyone was ready to admit it. And the recognition, when it finally came late and came thin. In 1972, the Royal Astronomical Society awarded him its gold medal, the highest honor in the field, often described as astronomy's equivalent of a Nobel Prize, citing his work on neutron stars and dark matter and his catalogues of galaxies. He was 74 years old. He had been waiting, in effect, for 40 years. He died 2 years later, on February 8, 1974, 6 days before his 76th birthday, in Pasadena, and was buried back in Switzerland, in the canton he had been sent to as a boy. He died before the rotation curve evidence had fully cemented dark matter into the foundations of cosmology. He died before the bullet cluster. He died before anyone built a mile-deep tank of xenon to hunt for the thing he named. He was right, and he knew he was right. And he died still mostly unacknowledged for the single most important thing he ever found. I find myself wondering what those last years were actually like for him, down in the engine room, barred from the telescopes, knowing what he knew, because that is the cruelest part of being right too early. It is not that the world disagrees with you. It is that you can see the thing clearly. You have seen it for decades. You have published it. You have done the arithmetic 100 times, and you have to watch the entire field walk past it as though it were not there, year after year, while you grow old. He had named the largest constituent of the universe, and he had to spend 40 years being treated as a difficult man with an obscure hobby. The recognition that came in 1972, that gold medal, was real, and I am glad he lived to hold it. But a medal at 74 for work done at 35 is not vindication. It is an apology that arrives after the person has already paid the full price. He got to know at the very end that he had not been wrong. He did not get to see how spectacularly right he was, because the proof kept arriving for decades after they buried him. There is a line in the advanced version of this kind of story that I keep thinking about, the idea of the ironic parallel, where the personal circumstances of a scientist mirror the physics they discovered. And I do not think I have ever encountered a cleaner one than this. Fritz Zwicky spent his life proving that the most important matter in the universe is the matter you cannot see, the matter that is everywhere and exerts enormous influence and never shows itself, the matter that the bright shining visible things are merely floating on top of. And he himself became exactly that, in the social universe of his field. The invisible mass, the thing whose gravity shaped everything around it, while the bright famous names floated on the surface, getting the credit, getting cited, getting written into the textbooks. He was the dark matter of 20th century astronomy, present, dominant, decisive, and unseen. And the universe, it turns out, is built the same way. I want to slow down now, because we are reaching the part that I genuinely do not know how to make peace with, and I think it is the part that should stay with you after you stop listening to this. Go back to the numbers, but this time do not think of them as cosmology. Think of them as a description of where you live. Everything you have ever seen with your eyes or through any instrument, every star in the night sky, every galaxy in every photograph, every planet, every comet, the sun, the earth, the oceans, the trees, the buildings, the people, every atom of your own body, the iron in your blood and the calcium in your bones, and the carbon in every cell, all of it together, the entire luminous catalogue of existence, adds up to less than 5% of what is out there. If you took the total contents of the universe and reduced it to $1, then everything that has ever been seen, everything science was historically about, would be worth about a nickel. Or set the mysterious dark energy aside and look just at the matter, the stuff that clumps and pulls. Picture a beach, the whole sweep of it, every grain of sand from the waterline to the dunes. Now imagine that the bright matter, the stars and planets and gas and dust and people, all of it is one handful of that sand, and the rest of the entire beach, every other grain. Stretching out of sight in both directions is the dark matter. That is roughly the ratio. We are the handful. We have spent the whole of human history studying the handful, naming the grains in it, building our religions and our sciences and our sense of our own importance out of the handful, and calling it the universe. And the beach has been there the whole time, all around us, unexamined, because the handful is the only part that catches the light. The dark matter, the invisible majority, is not somewhere far away. That is the part people get wrong, because the word dark makes it sound like a distant region, like the dark side of the moon. It is not a place, it is here. The halo of dark matter that surrounds our galaxy passes through the room you are sitting in, through the walls, through the chair, through you, constantly. By most estimates, dark matter particles are streaming through your body by the billions every second. And they do not stop, and they do not interact, and you cannot feel them, and you never will. As you sit there, an invisible substance that outweighs everything you have ever known is flowing through you like wind through a screen door, and the only reason you do not notice is that it has almost nothing to say to the kind of matter you are made of. Think about how strange that is. Everything you have ever called solid, the floor, your own hand, the device you are holding, is solid only because of the way ordinary matter pushes against ordinary matter, the electrical resistance of atoms refusing to overlap. Dark matter does not play that game. To dark matter, the Earth is not an obstacle. The entire planet, 8,000 miles of rock and iron, is something it drifts through the way you drift through a patch of fog. Right now there is dark matter passing up through the floor beneath you, through your body and out through the ceiling, and at the same moment more of it is passing down through the sky, through the roof, through you, and into the ground, and the two streams do not collide, and neither one touches you, and there is more total mass in that silent traffic than in everything you will ever see in your life. We have spent our whole existence as a species believing we lived on solid ground in a solid world. We live in a sieve, in a current, in a tide of something that treats all our solidity as empty space. And it was here before us, and it shaped the galaxy that made our sun, and it will keep flowing through the place where we used to be long after we are gone. And here is the thought that I cannot put down. You are made of the rare stuff, not the normal stuff, the rare stuff. For most of human history, we assumed that we were made of the ordinary material of the cosmos, that the stars were made of the same things we were, that to study the universe was to study, in some sense, ourselves writ large. That assumption is now backwards. The matter that makes up stars and planets and people is the exotic minority, the strange bright contaminant, the 5% impurity. The normal material of the universe, the default, the overwhelming majority, is the dark stuff. We are not the rule. We are the exception. We are the thin, shining scum on the surface of a dark ocean, and we spent our entire history believing the scum was the sea. There is something about that inversion that the universe seems almost to insist on, the longer you look. Because consider what the dark matter actually does. It does not just sit there as inert mass. It is the scaffolding on which everything visible is built. In the early universe, it was the dark matter that clumped together first, under its own gravity, into a vast invisible web of filaments and knots spanning the whole of space. And then the ordinary matter, the gas that would become stars and galaxies, fell into those invisible wells, settling into the gravitational valleys that the dark matter had already carved. Every galaxy you have ever seen formed inside a dark matter halo that came first. The bright cities of stars are sitting in invisible foundations that were poured before the first star ever lit. The structure of the entire visible universe, the great cosmic web of galaxies and clusters and voids, is a faint luminous tracing of a dark architecture that we cannot see and did not design and do not understand. The light is decoration. The dark is the building. We can actually test this, and the test is one of the eeriest results in modern cosmology. Take the most powerful supercomputers we have, load in the laws of physics, and simulate the evolution of the universe from shortly after the Big Bang to the present day. If you run that simulation with only ordinary matter, the kind we are made of, you get the wrong universe. The gas spreads out, gravity works too slowly, and by the present day you have a thin, smooth, structureless soup. No galaxies like ours, no grand spiral arms, no clusters. Not enough time for any of it to form. The visible matter, left to itself, cannot build the cosmos we live in. But add the dark matter, let it clump first and carve out its invisible wells. Let the ordinary gas fall into those wells, and the simulation produces a universe that looks exactly like ours, down to the fine details of how galaxies are strung along filaments with vast empty voids between them. Which means something that I think people do not sit with often enough. The galaxies exist because the dark matter exists. The stars formed because the dark matter gathered the gas. You are alive. Your sun is burning. Your planet formed because 85% of the matter in the universe did the gravitational labor of building the structures that everything else fell into. The invisible majority is not just the largest part of the universe. It is the reason there is anything in the universe worth seeing at all. We owe our entire existence to a substance we have never touched and cannot name. When you phrase it that way, and I think it is the honest way to phrase it, the universe starts to feel less like a passive collection of stuff and more like something with a hidden order, a structure that decides where the visible things are allowed to be, that holds the galaxies in formations they could never maintain on their own, that has been quietly determining the shape of everything since before there was anything to see. I am not saying it is alive. I am not saying it watches. I am saying that the thing that actually governs the large-scale structure of reality is invisible to us, was here before us, will be here after us, flows through us without acknowledgement, and does not answer to any question we have learned how to ask. That is not the comforting universe of the textbooks, the knowable one, the one made of the same atoms we are made of. That is a universe in which we are the rare local accident, clinging to the 5% we happen to be built from. Surrounded on all sides and shot through at every moment, by a vast invisible majority that is, by every measure that matters, what the universe actually is. A difficult man saw the edge of this in 1933. He saw a swarm of galaxies moving too fast to be held by anything visible, and he understood, before anyone was ready to understand it, that the visible was not the point, that the visible had never been the point, that we had built our entire picture of reality out of the small bright minority and called it the whole. He named the majority. He published the name. And his field, made of people, made of ordinary 5% matter like you and me, did the most human thing imaginable. It looked at a truth too large to absorb, and it looked away for 40 years, and it let the man who found it sink quietly into the basement and the silence and the dark. And we are, in a sense, still looking away, just in a more sophisticated manner. We have accepted that dark matter exists. We put it in the textbooks now. We give it a confident name. But acceptance is not the same as understanding. And I think the confident name lets us avoid feeling the full strangeness of the situation, which is that we are a technological civilization that has mapped the cosmic microwave background and detected gravitational waves and landed machines on other worlds. And we cannot tell you what most of the universe is made of. Not most of the distant universe, most of the universe in this room. There is a real possibility, taken seriously by serious people now, that we never will. That the answer requires physics we have not invented and may not be capable of inventing. That this is not a temporary gap, a problem awaiting its solution, but a permanent feature of the human condition. That we are creatures who will live and die inside a universe whose basic composition is hidden from us, able to measure its weight and feel its pull and never once see its face. We have gotten very good at living with that quietly. Zwicky never learned to live with it quietly. Maybe that was the real thing they could not forgive him for. He kept insisting on the size of what we did not know. And there are few things a confident field finds more irritating than someone who will not stop pointing at the hole in the floor. Here is the last thing, and then I will leave you with it. That velocity dispersion Zwicky measured for the Coma cluster back in 1933 from his sample of just 8 galaxies was 1,019 kilometers per second. Decades later, with modern instruments, and the velocities of more than 1,000 galaxies measured precisely, the accepted value for the Coma cluster's velocity dispersion is about 1,080. He was off by less than 6%, from 8 galaxies and a piece of 19th century arithmetic. Working with glass plates in the 1930s, a man measured the speed of the invisible universe and got it almost exactly right, and then watched his own field decide that getting it right did not count, because it had come from him, and because the answer was unbearable. That number, 1,019 kilometers per second, was the sound of the invisible majority moving, and he heard it correctly the first time, with almost nothing to work with, and then spent the rest of his life being told, in the polite professional language of people who do not want to deal with you, that he had not really heard anything at all. He had heard the largest thing there is. He had put his ear to a cluster of galaxies and heard the weight of the dark universe, and he transcribed it, and the transcription was right, and it sat in a journal being right, while the man grew old and angry and was moved to the basement and was forgotten and finally was given a medal too late and then was buried. And the thing he heard never stopped. That is the part I keep returning to. None of this stopped because we failed to understand it. The galaxies did not slow down to wait for us to catch up. The dark matter did not become less abundant because we could not name it. Our confusion changed nothing. The universe simply went on being mostly invisible, mostly unknown, mostly indifferent to whether the bright 5% ever figured out what the other 95 was. And it is going on being that way right now, in this room, in your body, while you sit here at the far end of the story Zwicky started. The galaxies in Coma are still moving at 1,000 kilometers a second. They have been the entire time you have been listening to this. They are held in place by something that has never been seen, that outweighs everything that shines by more than 5 to 1, that is flowing through your body right now, and will be flowing through it when you fall asleep tonight, and that no one on Earth, 90 years after it was found and named and published and ignored, can tell you the first true thing about. You are made of the part we understand. It is the smaller part, and the larger part has never once told us what it is.